Hello! Today we're going to be taking a look at a few debugging techniques in the R language. Most of this talk will cover basic techniques. If you're already comfortable with debugging in R, then take a 10-minute nap and I'll show you some new stuff at the end. Throughout this talk, I'm going to be using the RStudio IDE, but the ideas here should apply to whichever R environment you prefer. All right, let's get started. So here's some R code I've been working on for a Project Euler problem. The goal of this code is to find the largest number that is the product of two three-digit numbers and is also a palindrome, which is to say that the number is the same forward and backwards. Let's try out my solution. Well, that's not right. That's clearly not a palindrome. Does anyone see the error right away? Don't shout it out. Let's spend some time debugging this with the first tool in our arsenal, which is a function called appropriately enough debug. The debug function comes with R, and it can turn on debugging for any other function. I can already hear your next question, which is what happens if you call debug on itself? I tried this myself the other day. The answer is a tiny black hole. Let's turn on debugging for the palindrome function. Okay, now let's try running the palindrome function with a number that's actually a palindrome to see if it can detect it. We've just entered the debugger. Now, when you're in the debugger, you become a little bit like Neo in the Matrix. Time stops, you can look around, you can alter state, and you can move time forward at your leisure. So we're inside the palindrome function now, which means that we are inside its local function environment, and we can step through it. Let's take a look at the local environment. So there's num, that's the number that we passed in. Let's take a look at that. Yep, that's the number we passed in. As I mentioned before, we can also modify the environment if we're feeling especially evil. Let's change this to a different palindrome just for fun. All right, let's step through this function and see how it works. Now, the way this function works is to compute the number of digits that are in the number, loop over half of the digits, and compare them to the other half and see if they match. So under the debugger, we can step through the instructions one by one and see how the function works. So we can see we're getting the two places to compare, we're getting the two digits to compare, and then we're going to compare the digits. If you're especially observant, you've noticed that the two digits that we're comparing are 0 and 0. But the number from which they are drawn is 32123. Clearly, this is not good. We've got an error in our mathematics somewhere. I'll give you just a second to find it. Congratulations, you found it. We are using a modulo operator and a division operator on the same number. We need a modulo not by 10 to the power of the place, but 10 to the power of the place plus 1. Let's make that change. Great, I hope that fixes it. So to verify our fix, we're going to use another excellent debugging tool, which is called browser. Browser is an R command that invokes the debugger whenever it is encountered. Let's go ahead and add a browser statement here to the end of the palindrome function. Now we'll know which numbers the function considers to be palindrome when we run the outer function. Let's give it a try. So as you can see, R has executed until it encountered the browser statement, and then it stops and lets us look around. As you can see, the number that it considers to be a palindrome is 10201, which looks a lot like a palindrome. Let's let this run a few more times and see if all the numbers that it returns are in fact palindromes. Looks like a palindrome, looks like a palindrome, looks like a palindrome. I think we fixed the bug. Now let's go ahead and take that browser statement out of there because we probably don't want to leave it in our code. Another way of doing the same thing we just did is by using a breakpoint. In RStudio, setting a breakpoint is as easy as simply clicking to the left of the line number of the statement on which you want to set one. Now, breakpoints are a lot like browser statements, but they have the advantage that you can set them anytime. You notice I did not have to resource the file in order to make the breakpoint active. And as you can see, when I run the function again, it stops at this line of code just as though there were a browser right there. Now, I'm certain that at this point you are extremely curious about which number is in fact the biggest palindrome that is a product of two 3-digit numbers, so let's end that mystery right now. The answer is 906,609. Please go tell your friends. All right, let's switch gears a little bit and talk about error management. So here's a simple routine that I wrote that reverses every word in a sentence but doesn't reverse a sentence itself. Let me show you how it works. I call this crazify. You can crazify a sentence. Let's try the sentence, here I am at use R. As you can see, this turns it into the much more entertaining sentence, era I mata rezu. Now, this works great on one string, but I'd like to actually crazify an entire data frame full of sentences. So I've got a function to test my string crazifier on a data frame. Let's go ahead and run that. Oh, great. uh, as most of you already know, R is a terrible newspaper reporter when it comes to errors. When it comes to the 5 W's and an H, you get just one of the W's. It tells you what went wrong. It doesn't tell you what, when, where, why, and how, like a good reporter would. Let's try to get a little more information. If you're using RStudio, you can click Show Traceback to see where the error happened. It doesn't help a little. It helps a lot. You can see the exact line of code where the error occurred. If you're not using RStudio, you can get the same information by running a function called traceback. As you can see, R is giving me the same information here that RStudio does. So now I know what went wrong, and I know where it went wrong, but I don't really know why it went wrong. So to really get to the bottom of this, we kind of want to use our debugging skills that we just learned. We'd like to become Neo, like right at the very moment that the error occurred. R includes a facility built in to do just this. It's called options error. You can run any function you like when an error occurs. So let's have it run our good old friend, the browser function, when an error is encountered. Okay, well, the error is in string split, which is not useful. But if we go one up in the call stack, we can see exactly what's going on here. We can see that what we're trying to split is, in fact, not a string, but a factor. That's the source of our error. Let's try to correct the error by adding strings as factors equals false to our data frame. There we go. No more errors. Now that we've resolved the error, we probably want to turn that option off so that we don't keep jumping into the debugger every time an error happens. That would be a little bit annoying. Now, this pattern that you've just observed, wherein I turn on the error browser, run my code, and then turn it off, is so common that we actually built this functionality into RStudio. Let's remove this so that we get the error again, and I'll show you what I mean. Now, when I do this, you'll get this familiar error display. And the RStudio Error Inspector includes a rerun with the bug. And what this does is exactly what we just did. It turns on error browsing for the duration of one statement and then turns it off once we're done. So I'm going to click this. And as you can see, we're now exactly where the error occurred. And we can take a look at the state that caused it to occur. All right, so we've covered debugging your code. We've covered finding and fixing errors. But I also promised at the beginning of the talk that I'd show you some new stuff. So here are two of those new tools working together. You may remember in this crazy talk example that we reverse the characters in a string. And we do this using the rev function right here. Let's use some new tools to figure out how that function works. I'm going to set a breakpoint just like I did before. And I'm going to call test it. And we're going to stop right at where the function executes. Now, if you've used other debuggers, you'll notice that they often have a function called step into. And R just got this functionality as of R3.1. So in addition to stepping onto the next statement, I can actually step into the current statement and see how it works. Let's give it a try and see how the rev function works. Well, look, I've learned something already. Rev is actually a generic method. You can define an S3 generic for reverse however you like. The evil possibilities are endless. Let's keep on stepping in and see what we find. You'll notice here I'm stepping into unlist, and here we're actually stepping into rev itself. So this is the other new feature, and you may not have even noticed we were using it. In previous versions of RStudio, you had to have source references for a function in order to step into it, which means that you had to have built it yourself in most cases. Now RStudio can actually step through deparsed code. Take a look at the call stack. You'll notice that some of the items in the call stack are gray. That means that we don't have source code for them, but you'll still be able to use them with the debugger because they'll be deparsed. This means that you can debug R code no matter where it is. Here I'm stepping into R code that's part of R itself. In other cases, you can step into R code in other people's packages or even your own packages that you, for some reason, don't have the source references attached to. And finally, you can now see how the reverse function works. It's pretty clever. It simply creates a sequence here that's a backwards list of the indices of the vector and then returns the vector with those indices. All right, so we've covered debugging your code by setting breakpoints. We've covered error management, and we've taken a quick look at some of the new debugging functionality in R 3.1 and the newest release of RStudio. Thanks, and I will see you next time.